The Analysis Map software add-on provides a user-friendly interface to generate customized mappings of various mechanical characterizations. On the very top of the left panel, you will see the Open Map File button. By clicking this button, the user can open a previously saved map file that is either generated manually or semi-automatically using the Mach 1 Analysis Automated Indentation and Thickness Batch Analysis software add-on. The imported files will now show up under File List with their given file name. To the right of the File List heading, you will see the number of files selected. The user can select a single file by clicking on it in the file list. To select multiple files, hold down the Control key and make your selection. To select all files imported, check the Select All box found under the file list. Alternatively, the Shift key can be used in between the first and last selection. Once the file is selected, the associated characterizations are immediately shown in the Characterization List table. This table contains the category and characterization name as defined in the selected map files. Select the desired characterization by clicking on it from the list. Only a single characterization can be selected at a time. Below the characterization list is the Mapping button. After selecting both file and characterization, click on Mapping. Failure to select both before clicking Mapping will give the following error. Doing this correctly will open a window in the center of the screen prompting the user to select a reference image. This is the image of the sample surface where the mapped characterizations will be superimposed. The software will automatically suggest the corresponding image as it should be in the same folder as the characterization or map files. Select the file name and click OK. The mapping of the selected characterization will be generated on the selected image in the display panel of the software. Below the display panel, there are three checkboxes that control the viewing options of the display panel. The first is Mapping Visibility. By checking and unchecking, the software will toggle on and off the mapping of the selected characterization onto the reference image. The second checkbox allows the user to toggle on and off the Interpolate to Boundary option. If checked, a Kriging interpolation, which is a weighted distance interpolation of irregular spacing data points, will be used to obtain a complete mapping of the selected characterization. The basic idea of Kriging interpolation is to predict the value at a given point by computing weighted average of the known values of the function in the neighborhood of the point. The third checkbox allows the user to toggle on and off the data smoothing. If checked, the software will calculate a new value at each point, which is the average between the value of the point and the neighboring point based on the triangular mesh. There are more customizing commands accessible on a secondary panel to the right of the screen. The first section on the top right contains more visibility options for the selected characterizations mapped onto the displayed image. The middle section are controls for customizing these options based on user preference, and the last section on the bottom left includes more controls to customize the mapped data. Let's take a look at each individual option starting from the top right. The first checkbox is Position, which toggles on and off the visibility of the position markers or indicators in the display panel. The corresponding controls for this feature is the first row in the table shown here. The user can change the size of the position indicators by either using the arrow keys or inputting a value in the provided field. The box to the right of the indicator size allows the user to change the color of the position indicators. The next checkbox is Position ID, which toggles on and off the visibility of the position IDs or position number. If checked, a position number at the bottom right of each position indicator will be visible on the reference image. Once again, the corresponding controls for customizing this feature are the second row in the table shown here. The user can change the font size and color of the position ID. The next checkbox is Boundaries, which toggles on and off the visibility of the boundaries defined for each subsurface. The user can change the line width and color of the boundary from the third row in the table. The next checkbox is Triangles Mesh, which toggles on and off the visibility of the triangular mesh on the reference image. The corresponding controls are located in the fourth row of this table, where the user can change the line width and color of the triangular mesh. The Delaunay triangulation method is used to divide the selected subsurface into a set of triangles to generate a color mapping. The next checkbox is Mapping Values, which toggles on and off the visibility of the mapping values on the reference image. From the last row of the table shown, the user can change the font size, color, and significant digits of the mapped values shown on the reference image. To restore the default values, right-click in the desired box and select Reinitialize to default value. Other advanced features are available to customize mapping of the selected characterization. To show you these features, I will toggle off the visibility of the previous features. The first checkbox in this section is the Mapping Log Scale. If selected, a natural logarithmic scale will be used to generate the mapping of the selected characterization on the selected subsurface. If deselected, a linear scale will be used. The next checkbox is Mapping Autoscale. If selected, the maximal and minimal value of the scale will be automatically set by the software for the selected characterization. By unchecking the Mapping Autoscale box, the maximal and minimal fields become available and allows the user to define maximum and minimum limits of the scale. The Mapping Opacity allows the user to set the transparency of the mapping when overlaid on the image, where 0 being 0% opaque and complete transparency, and 1 being 100% opaque and no transparency. The Color Map option provides a list of color map types that the user can select. The color map can be inverted by checking the Invert Color Map box. The user can adjust the transparency of the scale by clicking on Adjust Transparency of Scale button below the scale. The software will prompt the user to select the background color of the scale by clicking on the desired color in the image. For example, selecting a dark or light color will change the transparency of the scale accordingly. This is useful if you have modified the opacity of the mapping displayed and would like to have the same level of transparency set for the scale for a uniform representation of mapped values. The Analysis Map tool also provides the sample information and a statistical summary in the table below the display panel. The sample information contains the characterization name and the associated information. The user must import a map file containing a column named Sample Info for data in this section to appear. The statistics section contains the mean, standard deviation, number of points, maximum and minimum columns of each subsurface ID defined. Once satisfied with the characterization mapped onto the sample surface, the user can save an image by clicking on the Save Image button. This function saves a JPEG image of the display panel as shown after user specifies an appropriate name and file location. And lastly, the Save Scale button saves the scale after user specifies an appropriate name and file location. Here is an example of a rat cartilage with instantaneous modulus at 20% strain mapped onto the sample surface.